Thank you for joining us this afternoon. Technology and nature, two things we all love and we all depending on, are often enough two competing concepts. Yeah? You cannot put it otherwise. Today we're going to talk about things like remote sensing, about geodata, geodata-based services, microsatellites, and we try to find out how these seemingly competing concepts could overlap and maybe help each other. I'm very happy today to have here Zach Manchester. Zach is an assistant professor in Stanford. He founded crowdfunding for democratization of space travel. Aurélie is a remote sensing specialist at the World Wide Fund for Nature. Yeah, now I got it right. And Manfred founded Cloudeo. And Cloudeo is a digital platform where you can have access to 90% of all relevant Earth observation data today. You can check it out on www.cloudeo-ag.com. And let me start with a first question to you, Aurélie. Today, in your job, what kind of technology are you implementing to save animals against poaching?
So I'm a remote sensing specialist. So we use satellite imagery where possible. We can map habitats where elephants or rhinos are, their corridors where we live using satellite imagery. And our anti-poaching efforts, as you saw what Marco presented, involve aerial surveys or drones to relay information from the ground to the ranger teams, wherever they are, to help them get there in time before the poaching event happens.
So, Zach, you have developed microsensors. Yeah? Tell us a bit about the potential use and the scalability and your vision of implementing these kind of technologies.
Yeah, so just to give everyone an idea of what we're talking about here.
This is so cool. I was looking at it before.
This is the world's smallest satellite, and there's a few of these on orbit right now, actually. If you want to see these later, come up and talk to me. But I guess the message that I really want to get across is that, I mean, many of you have probably heard of new space, and it's been a very exciting sort of last 5 years in the space industry with miniaturization, small satellites, and lower cost. But I think an observation, about this whole scene is that while costs have been going down as a result of these things, the players in new space are really still serving the same markets as the traditional spacecraft companies, right? So you're still seeing remote sensing and imagery from these new startups like Planet Labs, and we haven't really seen the emergence of kind of wholly new applications or markets as a result of the lowering of costs. And I think that's on the horizon. I think we've seen the costs associated with launching a spacecraft go down 3 to 4 orders of magnitude, right? It's incredible. And I think one of the things that I'm really excited about is kind of as part of this kind of Internet of Things emergence, I think we're going to start to see applications where we have in situ measurements being made by tiny tags, tiny sensors in the wild, and exfiltrating that data, getting that data back via satellite. So one of the problems with the Internet of Things and these small sensors right now is that they rely on ground-based infrastructure to get the data off of the tags, right? So you can imagine there's lots of that where there are people, but if you want to put these on animals, there's not cell towers, where the animals are, generally speaking. And so I think there's a huge potential here for actually doing new things in situ sensing using spacecraft, in addition to the remote sensing things that we do now.
And Manfred, the access to data on your platform provides and enables tons of new services today. Especially the combination of different data sets has a huge power. So could you come up maybe with a few examples where your technology, your combination of data sets could actually help Aurélie in her fight against poaching, for example?
Yeah, maybe let me start quickly to draw some comparison to what we heard just from Zach, because in a way we do something similar. I mean, today it's if you want to work with remote sensing data, you have to buy them, you have to build your architecture. In a way, what you do, you build up your complete process flow from scratch every time. So it's the reason why this market today has mainly project-based business. And what we do with the platform, with Cloudio platform, is actually to take away this entry barrier, that you have a platform, you find everything to work with, you find access to the data, you find software, and you can automate processes. So instead of talking about a project at several 10,000s maybe, you talk about 10 euros, 50 euros of service, which you can do automatically. So to your question now, there are, for example, as you can imagine, the capability to monitor the Earth has an impact to almost everything humans do. So it is from agricultural to maritime, protection of the environment. I mean, all different types of applications. And what we have, for example, is we have a service using AIS data. So this is not really remote sensing, but it's the collection of all the ship data which is collected by satellites. If you combine this with radar satellite data, which can detect where ships are, where ice is, where oil spills are, you have a whole set of applications which you can immediately use. And that's what Cloudio does. It does provide this platform that these type of operational services can be realized very fast and cheap.
So, Orly, what is the main content of data that you use today? And do you see in any of this what Manfred just mentioned, where you could see a use that you are not using today?
Yeah, so there's a lot of data out there, and there's no one data for everything. Using EO data is a little bit like picking out curtains, right? You don't put all the same curtains on every window in your apartment. You have certain curtains that are certain prices and do different things. And so we use a whole suite of imagery, whether it's Landsat, which goes back in time, to the 80s, so it's great for change detection, to the newer high-resolution satellites that are now taken these days, and the new ESA satellites and Planet and so on. So we use whatever we can get our hands on. And yeah, combining them can be a little bit tough, as Manfred explained. So having a system like that where you could put them all together and really get the best out of both worlds. Particularly, I am interested in this overlap between optical and radar, and even just how you said. So the ESA satellites are free, radar data and optical data. So radar is active, it sees through clouds and kind of detects something different as opposed to optical, which is taking a photo. So places where we have lots of clouds or things like that, the radar data is great. But radar data is notoriously difficult to use. It's not really accessible for people. I have a hard time using it in my daily job. So having a way to combine it would be great. Coming back to the AIS data, that's really interesting. You saw Marco just presented the whole fishing thing, the transparency of the fishing. AIS data is one of the data sets we do have access to, and we use that to try to look at where all the European ships are when they're fishing. They're all off the coast of West Africa, and they do kind of maybe shifty things. They turn off their AIS devices when they're near protected areas and perhaps fishing or whatever. So anyway, these kind of things can be just really important for tracking illegal trade, illegal activity, and so on. I can see it being extremely valuable.
Are you buying your data today, or is it just data that you collect yourself with drones and sensors?
So of course, free data is great, but with satellite imagery, you sort of get what you pay for. So when you pay for data, you usually get better quality, better response, and better resolution, and all of that. So we do have to buy data, unfortunately. We don't have a lot of money, but we do invest wherever we can when we can afford it to buy data.
Maybe this could be a great match today, because the data that is accessible on Manfred's platform has a price reduction of 95% compared to if you buy satellite data. Yeah? This could be very
we negotiate a little bit of reduction. Thankfully, a lot of companies are really nice, and they know they like WWF, and they'll give us reductions. Nothing is close to 95%, but so that's good to know.
Good. So, Zach, you were just talking about the in-situ data, yeah? I could imagine a huge problem is getting the data actually out of remote places to where you actually need them. How you cope with this kind of obstacles?
Right, I think Arlie, could probably talk to applications where there's just things you can't measure remotely, right? There's stuff you can't see in a picture or in a radar image that you might want to measure. There's numerous applications in agriculture, say, monitoring chemistry in soils, water quality, these sort of things where you really need to have a sensor in the physical environment, right? And the problem is that you just don't have infrastructure in many of these out-of-the-way places to get the data back. And I think with the just tremendous reduction in cost associated with launching small satellites now, I think on the horizon coming up soon, we'll be able to have networks of satellites in low Earth orbit that can actually collect this data from very small sort of Internet of Things style tags that use energy harvesting and can sort of be dropped off in the environment, left for years, harvest solar power, be very small, very unobtrusive, and we can get this data all over the world in very out-of-the-way places.
If I understood correctly, you're also a specialist on free space laser communication, a bit, yeah? It's in your field. Is this going forward, could this be a possibility actually to extract data from remote places?
So the problem with the laser comm stuff is that it requires really fine pointing. So the laser comm, for those who don't know, so most satellite communication today is done with radio, with an antenna and all this. Laser communication is kind of the new hot thing in spacecraft communication, and it's what it sounds like. Use a laser instead of a radio to send data, and you kind of pulse the laser to encode bits. So the great thing about this is lasers can be focused down to a really tight beam, and that lets you get extremely high data rates with very small apertures. You can have a tiny little laser and have it focused very tightly, so you can achieve really high data rates with low power. The problem is that the hardware associated with the ground segment, what you need on the ground to transmit and receive this, is a big telescope. And typically, these are sort of meter-size aperture telescopes. So I think there's great potential for this in fields where you need to get a lot of data down very quickly. So for remote sensing, where you have these huge data sets with lots of images, it could be a game changer there. For these kind of tiny in-situ sensing applications, you can't have the communication hardware to do laser comm on these tiny tags. So these would be probably RF and probably very low power RF and very low data rates, but they would send you little packets of data like locations with timestamps on them, information about chemical concentrations in the environment, things like this, things that can be summed up in a few numbers and put in a tiny packet that doesn't require a lot of bandwidth. I think that's can be done.
Like a gunshot sensor or something. You have a bunch of sensors somewhere, it hears a gunshot, that tells you where the location or triangulates the location, that could send it in a little package.
This is sound, yeah.
Sound
Understand. But did you know here in Munich we have actually a company called Mynaric. You can check it out on mynaric.com, yeah, and they are actually a technology world market leader when it comes to laser free space communication. You should check it out. So I am an investor in technologies, yeah, and from my point of view, most of the time when technologies get implemented, yeah, they need kind of a commercial application. Where do you see overlaps, and this question goes to all three of you, overlaps of commercial applications that also help protecting our environment? Or maybe you start.
I know he's going to ask me first. Yeah, I mean, there's always a commercial application or a business case for everything. Fortunately, well, there's not too much business to be made in protecting the environment, but yeah, I'd have to see somewhere. I could think of things like the timber industry as one idea. We try to make sustainable timber methods. We have companies, right, extracting wood from forests. If we found a way to make their activities more effective, more efficient, and maybe more sustainable, and they could sell it on the market as a sustainable wood, like FSC, for example, then I could see that as like a potential business application. Or the fishing stuff. Same thing with the MSC fishing certification. If we could kind of put that in the markets, maybe that's where the business case can help the environment. And what we need really is for companies and so on to want to do better, want to look better, and want to do more for the environment.
Manfred, anything to add to this?
Yeah, maybe one example. We had intensive talks with gas and oil companies. That's one thing.
Blacklist.
What their interest was, they wanted to use the satellite like the AIS data, as I said before, together with the radar satellite to detect oil slicks. And they wanted to be the first determining if around an oil rig there is an oil spill appearing, and they wanted to be the first to know maybe it was a ship and not the oil rig, because they were afraid that if there's oil coming across an oil rig, automatically everybody would point to them, and that would be a traumatic damage to them, because they would state that a lot of these oil slicks are coming actually from ships. So that's interesting, because at the same time it helps protecting, but actually at the end it's a commercial interest of the one who might be the producer of the oil slicks.
So one more, that may be slightly more palatable than oil and gas. I don't know if you can, is defense is another one, right? Where you can imagine people wanting to get data out of faraway places and this kind of thing, and someone that would have the appetite for these kind of big upfront infrastructure investments that are needed for this, that might have other customers later.
Please.
Yeah, of course I could now talk hours because there are so many applications. One is change detection, for example. Today, with the existing satellites like the Landsat or the Sentinel satellites, the European one, it becomes now feasible that you do automated change detection, that every week in a way you fly over the same area and you automatically detect if there are any changes, and specifically for again, interesting for gas pipelines, for example. If there's a leak, even for underground gas pipelines, if there's a leak, you would find that the vegetation in little spots is going to deteriorate around this. So it's a way to detect early detection of those gas leaks if you just check the vegetation along the gas pipelines. And again, today, you have to do every time a project and build this up, but with these new platforms like ours, for example, you can really do a very cheap service automatically detecting those type of issues.
So one of the buzzwords at DLD this year is certainly blockchain. Yeah? So Manfred, I think we are all on the same page if we say that through Internet of Things we will see an explosion of data and data usage, and the data will grow exponentially. So you have founded a non-profit organization called Cloudeo Blockchain Network. You can check it out on www.cbn.foundation. And your mission is to put geodata and geodata-based services on the blockchain. Can you tell us a little bit more about this exciting project?
Yeah, I mentioned that what we do today with the existing one is that we take it from a few thousands to tens of euros, but still you have quite some effort underneath. You have financial transaction, you have to monitor what the suppliers deliver, there are invoices written, there's money transferred, and also, so if you think into the future, and if you think into the Internet of Things, that actually you want to enable a single chip, which might be pretty stupid, you want to enable this to draw on geointelligence, then you cannot go to tens of cents or services because the underlying effort is still too big. So the blockchain is a very logical step here, because with a smart contracting way that you can say that, okay, you launch a smart contract which describes the product, which kind of steers the production of that product, and at the same time, once this is given, automatically the value for that service is transferred without any central financing and so on. So in a way, it allows you to get one order of magnitude again down in the size of services you can offer. And then, by the way, this comes into play because in the future, if you have a chip, this chip needs the answer, should I move here or not? For example, if it's raining, is it a flood-prone area where it is? So it needs just this information, yes or no. So all it needs is a low data rate connection to the platform. It can launch a smart contract, and it receives this information, and there's little payment done for that service. And again, it just you don't have to transfer a huge amount of data. It's just simple answers to the question the device has. So it's a very natural way that all this comes together, and therefore the blockchain is the future for this type of services.
Interesting. So, Aurélie, you're taking care about large animals and small animals. What's actually the smallest thing that you think you can protect or detect with microchips or remote sensing?
Well, talking to Zach earlier, he says you can put some of these transmitters on birds or something. Butterflies, I think, even. I mean, it's kind of almost unlimited. I mean, of course, we're interested in elephants, rhinos, tigers, lions, and things like that, but I could see a lot of potential in having these small transmitters on indicator species or some crucial species of wildlife that really maybe demonstrates what's happening in the ecosystem. Or marine life, for example, is a really big one. Presence of sharks indicates whether an ecosystem is really functioning and together. So any of these marine species that are notoriously wide-ranging, wide-roaming, if we could see where they are at any time, also underwater, I think would be really, really amazing.
I can see that you're very enthusiastic about this, but it's also sad enough that we have to flood nature with microchips and technology actually to protect it, right?
Yeah, I hope it was, if you could make those microchips out of the biodegradable straws that Marco just talked about, then I think that would probably be better. But yeah, that's something to consider.
Zach, can you see one of your devices on a bird or on a tiger?
Yeah, absolutely. So actually, I have long-running collaboration with some ornithologists actually who do bird tracking all over the world, and that's one of the main drivers. I was part of a workshop a couple of years ago with ornithologists who are concerned with global migratory patterns for these birds, right? So these birds literally fly halfway around the world twice a year, and it's just hopeless to do that. So what many of these people do now is there's this amazing network of hobbyist birders all over the place that actually go physically find these birds and look at the little bracelets on them and upload these sightings to websites to try to track these things. But the idea of tracking them with existing radio tags is almost hopeless because of the range, right? And they're flying over oceans, and you just can't do that from the ground. You really need this sort of zoomed out global view of the world that you can only get from space. So I think it's absolutely critical to many of these applications. Same thing with marine animals, right? They're in the oceans. There's no cell towers out there. And that's super challenging technically as well for a number of reasons. But yeah, I would say I actually have collaborators who make extremely small, very, very innovative tracking tags for birds, and they get them down to 100 milligrams for really small birds. It's pretty amazing.
And Manfred, let's assume for a second you would have this kind of data sets, yeah, collected by animals or by trees, plants. Yeah, you have this in a way with change detection anyway when it comes to deforesting, if I understood you correctly. But what could you imagine with what kind of data sets you already own today? You could combine this kind of data sets to create added value for our release course.
It's what already said in the beginning, that in a way, the more different types of data and the more analytics you can put, and you can combine it maybe with big data analytics, something completely unrelated maybe. If you combine all that, then you get really good services. I mean, it's not just, just knowing the position of the bird probably is a good thing, but you have to put it in a context, and then maybe bringing that together with change detection service, with very high resolution imagery, maybe from a satellite, which you just put into with weather models, with any type of geospatial data, then you can really extract information which helps you with your problem. So it's always this combination of different ones, and this is the point where I think the future goes, that you can do very complex analysis, receive the answers through very low amount of data transmission like this. So this is where it all goes to.
Mm-hmm. So you just mentioned you already have weather data on your platform. Yeah?
We have all types. When we on the platform, satellite is just one. So, but we have aerial companies. We have weather data. We have this AIS data, which I called. We have soil data for agriculture. We have all different types of information. So anything which has a geolocation attached to the data is something we want to have in our offering for somebody to think about what can he do with all this data and derive a good service which would help a customer. So all different types of geodata. It's not just satellite data.
Okay, so and climate is also a topic that is close to your heart.
Climate's really important. You could combine, if you had these sensors like on birds, the migration, you could see the impact of the changing climate in one way, right? Birds migrate earlier or later, depending on the climate. You can combine it with the data from weather satellites. I mean, you'd have a really good view of where climate change is happening, how fast, and what the impacts are. And talking more about these combination of ideas, I can think about it again, illegal logging, for example. If we had these chips in trees or wood, you could see when this tree moves. The tree's not supposed to move, it moves. You get an alert. You can also see with the satellite image, with a really high resolution image, oh, there was a deforestation event. That's where that tree came from. Let's see where it goes. A lot of times, this wood crosses borders, right? This happens all the time. Ukraine might cut down trees, send it to Romania, and then it's called Romanian wood. Goes to IKEA, it turns into your coffee table. This is the kind of stuff where I think this technology would be really amazing to know, like where our wood is coming from and how it's, being handled.
And Zach, you're an assistant professor at Stanford. Congratulations, by the way. I think you got this post recently. Yeah. Great.
Been there a week.
And tell me, is environment in your studies or works at Stanford also a big topic? How much room does it take?
Yeah, so actually, I'm a new assistant professor in aerospace engineering, and the building directly across from mine is the environmental science building. And in fact, I spoke with people in that department when I interviewed for the job, and it's certainly, I hope there's future collaborations in the cards there. I think there's obvious overlap, and I think I certainly am thinking about these things. I think we all should be, and yeah, we'll see.
And Manfred, obviously you have an up and running business, yeah, with a lot of commercial clients. Do you also have clients already that are having like an, let's put it, altruistic cause or doing something good for the world or for our environment? How is the proportion of that? I would be interested in that.
Oil and gas.
Let me think about who do we have. I mean, we have, of course, local governments which are kind of taking water quality services. So is this altruistic? No, because it's in their kind of, they're supposed to take care of that. So I don't think we have a customer really which would do some stuff only altruistic for altruistic.
You told me about a use case. No, he has actually.
Yeah.
He maybe just forgotten about it, but you told me about a use case where it's about pollution. I think it was in Italy, I'm not sure, or in India. What it was a municipality, I think.
Yes, it was. But again, there was a municipality in Italy which came to us for a completely different thing. But then they saw that we have this kind of water quality product which we mainly sell into Australia right now. And they saw and they used this type of service then to kind of point to mafia which was clipping poisonous stuff into the sea or something. I not exactly know what the background was, but this was an example where they saw something for a different application and they used it then for checking. But again, not altruistic.
Well, a bit. Aurélie, where are you actually working?
Where? Oh, what regions?
Yes.
Everywhere. I live in Berlin, but we have my major project regions are in Africa, the Congo Basin, coastal East Africa, and southern Africa, and the large migration areas between Botswana, Namibia, Zambia, Zimbabwe, and Angola, the Kavango Zambezi, and then now I've started working more in Southeast Asia, so the greater Mekong region, where we work a lot with illegal logging, deforestation. Cambodia last year had one of the highest deforestation rates in the world. So kind of everywhere, and also, yeah, there's a couple projects in South America too. So I'm sort of responsible, or I help all of our offices worldwide access imagery and access imagery-related information. So.
Mm-hmm. And do you have the feeling that you are supported by the local governments, or is it more like an obstacle? Do you have to fight against, I don't know, existing commercial interests there, or is it more like a hand-in-hand work?
Hand in hand, I help the offices. So we have offices in over 100 countries. They come to me for help, or they need some. Yeah, they need a suggestion on a method or an algorithm, or they need some data, and then that's how I help them. So we have really good infrastructure, for example, in Germany, probably better than, let's say, Kinshasa and Democratic Republic of Congo. So I can download data or process it in the cloud or make products and then send it to our places there. So that's kind of how it works. So we don't really go through governments, if that was your question. We have to be careful, of course. We sometimes are seen as critical of the government, which is good and bad and has its downsides. But so that's kind of the approach we take, with a centralized processing structure in Europe and then disseminating the data throughout the world.
And is the technology of, what you call it, when you follow the course of...
change detection?
Change detection, you're right. Is the technology of change detection that you have at your fingertips today already something you implement in your work? For example, for deforestation or something like this?
Well, I would love to, but some of the, tropical deforestation is pretty easy to detect. Okay, Brazil, easy. Deforestation is the size of a football field, whatever. But when it gets smaller, deforestation, it becomes really hard. And in these environments like savannas or dry seasonal forests like you have in Cambodia, it becomes a lot harder to see when a tree is either being cut down or it just lost its leaves because it's seasonal. And so that's the kind of stuff I think we need a lot of help with. Being able to detect that reliably and automate it would be fantastic.
And Zach, do you, from your perspective, see an overlap with Cloudeo, for example?
Yeah, so I think I think we're just scratching the surface of what's possible from space with these kind of sensing applications. I think it's going to be a really interesting next sort of 5-10 years in this space. And I think you're going to see this kind of explosion of data, right? As we have more and more data, we're going to have to figure out what to do with it, how to deal with it, how to analyze it, how to disseminate it. And I think that's kind of what you're trying to address, right? So I think it's going to be huge in the next few years.
Yeah, I mean, what we hear today, you know, with this vision of having sensors on animals, on trees, I think it's also a big driver going forward when we think about and talk about Internet of Things. Yeah, it's going to be an explosion of connected devices. Yeah, and it's of course it's going to be one challenge to extract information actually from remote areas or even from animals that are living in remote areas. Yeah. The whole Internet of Things topic, yeah. How is what are the implications on data usage and data consumption from your point of view?
I think it's huge, really, because again, what is Internet of Things? It's really typically any little device having a certain function in the field, and with how does this device make its decision what to do? And so this device needs to have access to intelligence. And if there's a way to cheaply and communicate with this so that this little device can launch a smart contract or do business and go into platforms which provides them with knowledge, that's a huge application. Almost every, because again, chips or Internet of Things, they are there to have a special function. If there's no function, why should they be there? So there's a function, and usually, since most of the functions depend on the, or have something to do with the surrounding, then immediately there is a direct link with remote sensing. So, I believe there would be a very natural way that this there would be, it's coming together.
I think it's going to be, and I'm looking forward to this actually, very interesting to see how this newly sets of data that's going to be created by small sensors in remote places that will be, of course, adding data to your platform, yeah, what kind of impact this will have. Yeah? Also then vice versa, from a blockchain point of view, yeah, how you could actually track the amounts of mountain gorillas or something like this, you know, yeah. And it cannot be tampered with. It's just facts are created. Very, very, very interesting. Thank you very, very much. And I think, Aurélie, you wanted also to say something close to your heart about climate.
Oh, yeah. I just wanted to spread the word. WWF has a climate MOOC, massive online open course. It's all about climate. Chapter 1 is the difference between weather and climate. So all of you go into Davos, and if you see Mr. Trump, tell him to watch our MOOC and learn about climate change and what you can do.
Thank you very much. And we're here for questions.